food we consume has three main types of complex biomolecules. These are carbohydrates, proteins, and lipids. What will happen to these compounds when we eat them, when we consume them? During the digestion, these are broken down to simpler substances, and these simple molecules will be absorbed to blood and transported into the respective tissues and the cells for the metabolism. This table summarizes these simple molecules and the complex molecules I mentioned before. In this lesson, we will be learning the basic chemical aspects of these biomolecules. Carbohydrates. Let's have a look at the structure of glucose molecule, which is the building block of most of the carbohydrates. Glucose is a cyclic molecule with many hydroxyl groups. Let's simplify the structure of the glucose molecule. We only show only two hydroxyl groups and the rest of the part as a box. When two glucose molecules combine, we get disaccharide. Let's see how are they going to react. The first glucose molecule will give OH and the second glucose molecule will give H, removing a water molecule. So we all know then this is a condensation reaction. So what is going to be the connection between these two molecules? We can connect them via an oxygen atom, because you can see the OH and H removed. Now we can draw the other two hydroxyl groups. So what you get here is a disaccharide. This is a disaccharide. As an example, I can give you maltose. Hundreds or thousands of glucose molecules can join like this to form polysaccharides, such as starch, glycogen, and cellulose. Let's have a look at this process. Here are the glucose molecules. I have given three molecules, and the formation of this polymer can take place by eliminating water from either side of all these molecules. At this corner, hydrogen atom of this molecule will be eliminated with another OH group of the adjacent molecule, and that corner, the OH group is eliminated with another hydrogen atom of the adjacent molecule producing water. So water is going to be another product here. Here we have the polymer. So this is called polysaccharide. This is the fundamental structure of starch, glycogen, and cellulose. There are differences, but the basic structure is this. Can we write a balanced chemical equation for this? Yes, we can take glucose as the monomer, and let's try to figure out the repeating unit. The repeating unit will include a part of a glucose molecule and one oxygen, because this oxygen is repeated again and again. So I can write the repeating unit like this. So it's going to be n times in the polymer, and n number of glucose molecules are needed. So the linkage here found in the polymer is not an ester linkage, neither it's amide linkage. It's a different one. So the polysaccharides we get like this are condensation polymers. You understood? When they form, a water molecule is removed between two molecules. What happens when we consume these complex carbohydrates? the reverse reaction happens. The polymer is broken down back to glucose by adding water molecule across the linkage due to the action of enzymes. This breaking of the polymer back to glucose molecules using water is called hydrolysis. The hydrolysis is the exact reverse reaction of the condensation. Proteins are polymers built up from amino acids. These are three basic amino acids you can find in our body: glycine, alanine, and cysteine. An amino acid has a carboxylic group and also an amine group. It has some other groups also, but they have been simplified into this box. Since amino acids contain both these groups, amino acids can undergo condensation polymerization to produce a polyamide. Hundreds or thousands of amino acids can join to form a protein. You can see the OH group of the carboxylic acid and the H atom of amino group can form water, and it can continue from this end and also from the other end as well. Let's try to draw the polymer. We have NH, C double bonded O, NH again, C double bonded O, NH again, and C double bonded O. Proteins are also condensation polymers. When amino acids combine like this, you can see the usual amide bond can be seen after every repeating unit. Unlike nylon, which is a polyamide, proteins have one type of monomer. We know that is amino acids. But we have different types of amino acids. As a result, I have indicated that three different amino acids have combined to form this part of the protein. The structure of a functional protein is more complicated than what you see here. For your understanding, let's have a look at the 3D model of the spike protein of coronavirus. When we consume food with proteins, these proteins will be digested in our body. These complex molecules are broken down to amino acids due to the action of enzymes when water is present. This process is called again the hydrolysis. Lipids, glycerol and fatty acid molecules undergo condensation reactions to form esters, which are called lipids. The most important thing about the lipids is that lipids are not polymers. True, they are big esters and they form via condensation reaction, yet they are not polymers. Now we'll see what are fatty acids. Fatty acids are big carboxylic acid molecules with long chain hydrocarbon tail. This hydrocarbon tail can be saturated or unsaturated, which means the hydrocarbon tail may contain carbon-carbon double bond or not. Let's have a look at the structures of some common fatty acids. Let me write a general formula of carboxylic acid to represent a fatty acid. What is a glycerol molecule? It is an alcohol molecule with 3 carbon atoms, and the special thing is each carbon atom has one OH group attached. Here is the glycerol molecule. You can see there are 3 carbon atoms and each carbon atom has one hydroxyl group attached. How does this esterification occur? We need 3 carboxylic acid molecules to react with one glycerol molecule. Let me draw 2 more carboxylic acids here and we'll see how the esterification is going to take place. It's a special alcohol, isn't it? We have 3 hydroxyl group. Individually they are going to do esterification with 3 different carboxylic acids. The removal of water molecule and will give you a big ester. Let's see how we draw this. This is your lipid. It's an ester made by fatty acids and glycerol. The reaction is also condensation reaction. But I emphasize again, it is not a polymerization reaction. Let's summarize the formation of a lipid. 3 fatty acid molecules react with 1 molecule of glycerol molecule and to give you 1 molecule of lipid and 3 molecules of water. You don't have to memorize the structures again. Yet, when the structure of a lipid is given, you should be able to figure out it's an ester. What will happen when we consume lipids? The lipids in our food will be digested and broken down to fatty acids and glycerol again. And this process is again the reverse condensation, catalyzed by enzymes. Here are the 3 complex substances that we learned under this topic. Polysaccharides made from glucose, proteins made from amino acids, lipids made from fatty acids and glycerol. Polysaccharides are polymers. Proteins are also polymers, but essentially you have to remember lipids are simple molecular. The linkage in polysaccharides we don't have to learn in our syllabus. We usually call it glycosidic bond. The proteins, the linkage is amide, and the lipids, the linkage is ester. The type of reaction which produces all these 3 complex molecules is condensation. Hope you enjoyed this lesson and learned about the biomolecules in detail, what is necessary for your syllabus. Thank you.